want to figure out this waiting time limit, and we need to collect some data. So one of the things we need to do is figure out how we are going to sample. We can't go, and we don't want to go to every store and conduct this study in every store. There's going to be certain stores, and you mentioned some of the reasons why we'd select a store or why we would not select a store. But one of the things we want to make sure is that we want to have a sample. And there are various ways that we can sample. So I'm going to show you this quick video that hopefully has sound today. It lasts about 4.5 minutes. And then we're going to talk about these various sampling techniques, of which there are 5 that I'd like you to know about. So let's try again. Let's see. Back to the beginning. And we will try, I think we're going to have sound tonight.
Sampling. Simple, convenience, systematic, cluster, and stratified. To find things out about a population of interest, it is common practice to take a sample. A sample is a selection of objects or observations taken from the population of interest. For example, a population might be all apples in an orchard at a given time. We wish to know how big the apples are. We can't measure all of them, so we take a sample of some of them and measure them. The method chosen for taking the sample depends on the nature of the population and the resources available in terms of time and money. The ideal is for each object in the population to be equally likely to be chosen as part of the sample. This is called an unbiased sample. It is also desirable for the sample to be representative of the population. If the population of apples were 2/3 red and 1/3 green, the sample should be similarly split. Note that no matter what we do, there will always be sampling error or variation due to sampling, as we are looking at a part of the population, not the whole population. The video on variation covers these concepts more thoroughly. This video presents 5 methods of sampling: simple random sampling, convenient sampling, systematic sampling, cluster sampling, and stratified sampling. For each method, we will outline the process and the advantages and disadvantages. Simple random sample. Simple random sampling is theoretically the ideal method of sampling. You list each member of the population and use random numbers to decide which objects are in the sample. Each object is equally likely to be selected. This produces an unbiased sample, which we hope is representative. However, it can be difficult and expensive to take a simple random sample when dealing with people. Simple random sampling is more practical when the population is geographically concentrated and when a good sampling frame exists. A sampling frame is a list of all the people or objects in the population of interest. Simple random sampling can be more easily implemented for natural and manufacturing populations. Convenient sample. Convenient sampling is just that, convenient. You ask people nearby, or people who walk past at a shopping mall. Or you take the next 20 objects off the production line. You do what is easy or convenient. Convenient samples are often biased in some way, but for a quick and cheap poll, it may not really matter. Convenient samples can also have self-selection bias when people choose to participate because they have an interest in the issue in question. Systematic sampling. With systematic sampling, you choose a starting point at random and then systematically take objects at a certain number apart. For example, if there are 1,000 in the population and you want a sample of 50, you would take every 20th object. Systematic samples are easier to administer than simple random samples and are usually a good approximation of a random sample. However, if there is a pattern in the population, certain types of objects could be chosen more or less often than others. Cluster sampling. In cluster sampling, the population is divided into clusters which are then chosen at random. For example, departments of a business can be clusters, or suburbs within a city. Within each cluster, all of the objects are included in the sample. Cluster sampling can be more convenient and practical than simple random sampling. However, if the clusters are different from each other with regard to the elements we are measuring, it can lead to bias or non-representativeness. Stratified sampling. Stratified sampling seems like cluster sampling, but but the strata or groups are chosen specifically to represent different characteristics within the population, such as ethnicity, location, age, or occupation. Within each group, a random sample is taken, sometimes in proportion to the size of the group. Stratified sampling can lead to a very good random representative sample. However, it can be complex to administer, and a sampling frame with considerable information about the population is required. There are other sampling methods. The 5 explained here give an idea of the advantages and disadvantages of various methods. You should attempt to use the sampling method that produces the best result for the resources you have available. If your sample has known bias, this should be taken into account in analysis and reporting.
Okay, a lot of information in a short period of time, so let's go back and review each one of those 5 types of sampling techniques. And maybe what we'll do is just reflect back on the McDonald's example, and you guys tell me how you would potentially execute each one of these sampling techniques with the McDonald's example. So just to review for a second. This lady introduced very rapidly 5 different sampling techniques. Well, I didn't write them up here, but I'll write them now. The 5 different techniques, I'm going to go through them one by one. Are going to be random, which we sometimes just call simple random, stratified, cluster, systematic, and convenient. And so if you think back to the example of the McDonald's stores, there was reportedly 6,289 stores, let's say, across the U.S. We'll go through each one of the sampling techniques. So the first one, and really the best from a pure research perspective, is a simple random sample. Somebody described to me how you might execute a simple random sample if you were going to select a simple random sample of, let's say, 200 of the McDonald's across the country in which to collect your data about waiting time. How might you do that? Somebody describe what a simple random sample of those McDonald's restaurants would be. How would we do that?
Just like close your eyes and pick random ones?
Yeah, or like the lady said, you know, get a list of all 6,289, right? And list them, generate a random number, and pick them. But the idea here is that every store, in this case, every McDonald's, okay, has the same chance of being selected. So it's like rolling dice, okay? It's absolutely random, okay? You're not influencing it whatsoever. You're not putting any conditions on it whatsoever. It's totally random. Does that make sense to everybody? All right, so that would be a simple random sample. Now let's look at the stratified. The stratified sample, we divide our sample into strata based on some criteria. And what the lady was talking about in the video was ethnicity, maybe education, something like that. Somebody tell me or give me an example of how we would apply a stratified sampling technique and what we might stratify if I was going to select a sample of a couple hundred McDonald's stores. What would I be worried about stratifying?
Like the population, like how many people live in each McDonald's, so like the size.
Yeah, maybe McDonald's has what they call high-volume stores and low-volume stores. You know, I don't know what that means, but maybe they have some sort of threshold that says, you know, the high-volume stores do this much business each week, low-volume stores, maybe they're smaller, maybe there's less staff, maybe they do less volume. So you might stratify on saying, before I even start, I'm going to divide this into what? The high volume and the low volume. Does that make sense? And so that might be our strata. What are some other strata that you might think about, though, if you wanted to cover the whole United States? Geographic regions. You might stratify middle of the country, the East Coast or West Coast, I don't know, right? But you would create some stratification, and then within that stratification, you then would say, let me make a random sample, okay? And let's say out of the 6,000, let's just make these arbitrary, but 4,000 were high-volume stores, and 2,289 were low-volume stores. Does that make sense? So when I selected my sample, if I was going to only select a sample 200 stores, I would like to certainly have what? More high-volume stores in my sample than low-volume stores, wouldn't I? Because there are more across the country. And in fact, I'd like to have them in about this same percentage. I'd like the split here in my sample to mirror the kind of percentages that are across the country. But that would be a stratified sample. Not a very complicated one, but it would be stratified. Questions on stratified sampling? Make sense? All right, let's take a look at another one. A cluster sample. So a cluster sample kind of looks and feels like a stratified sample, but it's slightly different. What you do is you randomly select clusters. So if I divide the population into clusters, and then what I do is I randomly select clusters, and then I look at every McDonald's store in that cluster. And somebody describe how, with our McDonald's example, that might be executed. Yeah, Kylie?
Pick a few states and use every McDonald's in that state.
That's the idea. In other words, what would happen, is, what Kylie said is the cluster might be a state. Okay, so there's 50 states. And then I randomly would pick some states. That's the random part. I randomly select the cluster. And then, once I do that, I am kind of obligated, if I'm doing this sampling, to have every McDonald's store in the state participate in my particular study. That make sense? That's different than stratification, okay? Because in the stratification, I just split right away based on some criteria. Clustering, I'm just saying, you know what? I can't travel to every goddamn state. If I select 200 stores, then, you know, they're in Minnesota, Alaska, Hawaii, Florida, New York, Connecticut, Texas, California. I don't have enough money to go to every state. So clustering actually allows us an opportunity to maybe save a little money, because now I select the clusters at random, and I have maybe 4 clusters or something. And then I go and spend time in California and Texas and that's what I do. So that's the advantage of clustering, the practical advantage. Questions on clustering? Systematic. Okay. And again, the video, the lady in the British accent in the video talked about systematic sampling. And this is pretty good. This is really practical. We select every CAFE store. You get a big list. Huge list. List has got 6,289 stores on it. And we say, oh, I need 200 stores. I got a list of 6,000. I need 200. I got a list of 6,000. So if I select every 30th one, right? If I divide 6,000 by 200, if I select every 30th one, I'll get to the end of the list and I'll have 200 stores. It's kind of random. There's a little bias in there because I'm just going every 30th one. And if it turns out that every 30th store is, got some pattern like she showed with the yellow apple, then I'm kind of screwed up. But it's a pretty convenient way to say that's what I'm going to do to random. That's called a systematic sample. Now, technically speaking, when you do the systematic sample, you don't always start with one. You roll a die, you select a coin, and you say, okay, I roll a die. I'm going to start with store number 6, if I get 6. So you even randomize where you start. Maybe you draw a deck of cards, 1 out of 52, and you say, oh, I'm going to start with store number 27 here, and then every 30th one after that. Okay. So you randomize the start point, and then you randomize by saying, well, how many selections will get me to the end of the list and still have 200 stores? Does that make sense? Now, you really want to use the whole list. You don't want to just say, okay, well, let's roll a die, and let's start with store number 5, and we'll take every 5th store. Because what would happen? If you took every 5th store,
You wouldn't reach them.
you're only working on the top of the list, right? And that presumes that there's no bias on the list. So you want to really work the whole list. Questions? Make sense? I know it's easy so far, right? So we talked about these two. Convenience sample. Convenience sample. Somebody give an example of what a convenience sample would be like in our problem here. What would you do? What's that? Oh, we don't have convenience sample. Our book doesn't recognize it as legitimate technique, but probably done most of the time. What would a convenience sample be?
Asking if people are there.
What's that?
Asking if people are present at the time.
No, just go to our local McDonald's. I mean, in other words, I'm not going to invest time, energy, money. I need the answer tomorrow, okay? Convenience sample is like, go to my local McDonald's. You go around the corner. You do the most convenient thing. Now, that convenience sample is not even, I don't think, mentioned in our book, but it is absolutely something you should know and understand. Because, I'm here to tell you that most questions that get asked in business are not well thought out. There are way more questions where somebody will come into your office at 4 o'clock one afternoon and say, Cynthia, I need this tomorrow. I need the answer to this question tomorrow. What's the average time that people wait in our McDonald's here in the northern Chicago area? So, now what is Cynthia going to do? She's certainly not going to, get a list, select a random sample, organize everything. She's going to do whatever she has to, okay? And so, unfortunately, just by default, convenience samples are used an awful lot because the answer has to occur 1 or 2 days from now. And so you might just go and actually go to your local McDonald's with a stopwatch. Now, there's a lot of bias there because, it's a convenience sample. Questions about the different sampling techniques? Okay, so for those of you who are following along in the book, this really is mostly section 1.3. I see a lot of you have have notes that I put up on Blackboard, and so you should have been able to follow along in the notes. Now, one of the other things we want to do tonight, we want to do